Hello, future engineers, subscribers, viewers, and students. Here are continuation of problems given as quiz in Algebra 0, 1, and 2. If you want to anticipate the solutions to these problems, you may do so by pausing the video. That should be your attitude towards preparing in engineering life or engineering courses. Find the missing number from the series 5, 10, 23, 48, then blank. So to solve this problem, let's have the conventional way. That is, we have to get the difference between adjacent terms of the series. So the difference here is, let's call the missing number as x. The difference here is 5. 23 minus 10 is 13. 48 minus 23 is 25. Then we do not know the difference here yet, but let's study the difference. So the difference further here is 8. This one is 25, 12. So the difference is 4. So we suspect that 12 plus 4 is 16. This may be 16, or it should be 16. Then 25 plus 16 is 41. And 48 plus 41 equals x, so which is 89, which is B. But let's have uh, another interpretation of these differences. 5 is 1 square plus 2 square actually. So that's the value of x, but let's have another way. Your interpretation may be different. 5 is 1 square plus 2 square. So call that x. So this is 5, this is 13, 25, then we do not know that yet. But 5 is 1 square plus 2 square. You have to visualize, or you have to think of it. 13 is 2 square plus 3 square. 4 plus 9 is 13. So 25 should be 3 square plus 4 square, which is true. So therefore, the next should be, difference here should be 4 square plus 5 square, which is 41, which is the same here. Here rather. So therefore, that's 41. That's why x is 48 plus 41, and that is equal to 89. So I presented two ways, and the results are the same. Find the sum of the first 10 twin primes. So these twin primes are, first, 3 plus 5. Next is 5 and 7, so plus 5 and 7. Next is 11 and 13. Then 17 and 19. Difference is 2. Then 29 and 31. Then 41 and 43. 59 and 61. 67, 71 and 73. So first, second, third, fourth, fifth, sixth, seventh, eighth. Two more. 101 and 103. And lastly, 107 and 109. So these are the first 10 twin primes. So adding, S is equal to 908. So next, problem 27. Find the term involving z to the 12 in the expansion of quantity z squared minus 1/2 close raised to 11. So the R term is n's combination m, first term, which is z squared in this case, raised to n minus m, then second term negative 1 half raised to m, where m is to be determined as long as it involves z to the 12. N is 11, and we do not know the position of that term, so that's why m is unknown and m is r minus 1. So we'll just set up the r term, which is n combination m, first term raised to n minus m, second term raised to m. Then it is equated to coefficient constant, then z to the 12. So substitute 11 combination m, quantity z squared to the 11 minus m, then quantity negative 1 half raised to m equals kz to the 12. So take note that 11 combination m is a constant, negative 1 half to the m is constant. Therefore, we only equate the exponent of z here to 12. So this is z to the 22 minus 2m. So z to the 22 minus 2m equals z to the 12. So 22 minus 2m equals 12. So that means 22 minus 12 is 10 divided by 2, 5. M is 5. Having found M is 5, then it is supposedly this 11 combination 5 and negative 1 half to the 5 that should only be calculated because 11 minus 5 is 6 times 2 is 12. This is already z to the 12. So the sixth term is 11 combination 5, first term z squared to the 11 minus 5, then negative 1 half to the 5. And negative 1 half to the 5 is negative 1 over 32. 11 combination 5 is, so combining, it is 11, the value of m is 5, and 5 is r minus 1. Therefore, r is 5 plus 1. So the term involving z to the 12 is the sixth term. But the important thing is this expression. So it is negative 231 over 16 z to the 12. Problem 28. There are 15 questions in a quiz and a student is required to answer any 10 of them. How many different sets of 10 questions can be selected? So this is choosing 11 questions out of 15, and choosing 10 questions from 15 is combinations of 10 objects from 15 or 15 combination 10, because in any order, as long as the 10 questions are the same, then that means they are of the same combinations. So this is combinations, not permutations, because questions 1 to 10 is the same as, for example, 1 to 10, it's the same as 10, 8, 9, 7, 6, 5, 4, 3, 2, 1. It's the same combination as long as the numbering is the same. So again, this is n is equal to 15 combination 10, and that is equal to 3003. So there are 3003 different sets of 10 questions from 15 that can be selected. 29. From the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 10 digits here. How many 3-digit numerals can be formed? So if it is a numeral, how many 3-digit numerals? It's not how many different 3-digit numerals. So meaning the digits may be repeated, but the numerals, the numbers can only be said to be numerals if they do not start with 0. So therefore, in the first position, there will be 9 ways to assign a digit there, so that the resulting 3-digit would be a numeral. So again, we draw 3 blanks. In the first position, we should assign numeral here, a number here, and there are 9 ways to assign a number here because 0 is not included. But on the next portion, because these are 3-digit numerals, not different, therefore the numbers, the digits can be repeated. And there are 10 available digits here. 0 is now included. So 10, then on the next position, 10 also. So 9 times 10 times 10 from the fundamental principle of counting is 900. Then the last question. Three numbers whose sum is 35 form a geometric sequence. If 1 is subtracted from the first number, 2 is subtracted from the second number, and 8 is subtracted from the third number, the resulting differences form an arithmetic sequence. What is the product of the numbers? Let the numbers be x, y, and z. So x plus y plus z is equal to 35. And we're looking for their product, so product is x times y times z. But we do not know yet x, y, and z. Then since this series of numbers form a geometric sequence, that means the middle term, the square of the middle term is the product of the first and the third. So y square equals xz. And also when 1 is subtracted, x minus 1, then y minus 2, then z minus 8 are in arithmetic progression. Since they are in arithmetic progression, second minus first equals third minus second. So y minus 2 minus quantity x minus 1 equals z minus 8 minus quantity y minus 2. So y minus 2 minus x plus 1 equals z minus 8 minus y plus 2. Simplifying, this is 2y, negative 2 plus 1, negative 1, plus 8, 7, minus 2, 5. So 2y plus 5 equals x plus z. So that's the equation. Then uh, next is we substitute z here. So x plus z equals x plus z plus y is 35. So that means replacing x plus z, which is equal to 2y plus 5, then plus y equals 35. 3y equals 35 minus 5, 30. Then we can now solve for y. Y is equal to 10. Having found y is 10, we substitute it here. 10 squared equals xz, and z is from here. Y is 10, z is 35 minus 10, 25 minus x. So anyway, we substitute y equals 10 here. 10 squared equals xz, and we replace z by 35 minus y, 35 minus 10 minus x, or 25 minus x. So z is 25 minus x. Substitute here, 100 equals x times quantity 25 minus x. Distribute, 100 equals 25x minus x squared, or x squared minus 25x plus 100 equals 0, which can be factored into x minus 5 and x minus 20 equals 0. So x is 5 and x is 20. When x is 5, then into this equation, z is 25 minus 5, so z is 20. And if x is 20, z is 25 minus 20, so 5. So the product therefore is xyz, which is 5 times 10 times 20, or 20 times 10 times 5, which is the same. So product equals 5 times 10 times 20, or 20 times 10 times 5. So the product is 1000. So that's it for this video. I hope that you were able to understand and follow the explanations and the solutions.